Hello. In this section, we're going to be working on what is known as factoring quadratics. In prior sections, we worked on adding and subtracting and then multiplying to make a quadratic. So we're just looking at the operations with them. And today we're going to be looking at what's the division version of it, which we call factoring. To start, if you would, try these questions just on the side of the note packet or maybe at the bottom of your last homework. The lead-in question is, what is a factor of 12? So factors are numbers that divide evenly into 12. Factors of 12 are going to be 1 and 12, 2 and 6, and then 3 and 4. And then you could have all the negative versions of those numbers as well. So those are all the factors of 12 because they divide evenly into 12. Now, the three questions I have for you is, can you find the two factors of 12 that add up to give you 8? Can you then find two factors of 32 that add together to make you 12? Can you find two factors of 24 that you can add together and get 10? So pause the video now for maybe a minute, give everyone a minute to try, and then come back after everyone's had a chance to try. Okay. Questions, although they seem like they wouldn't be connected to what we're going to be doing today, they actually are very much connected to what we're doing. That's why we're trying them as just kind of mental math puzzles to start. The two factors of 12 that I need to add together to make 8, those are going to be 2 and 6. 2 times 6 is 12, and 2 plus 6 is going to give us 8. What two factors of 32 can you add up to give us 12? Well, that would be 4 and 8. Both have to be positive. Last one, can you find two factors of 24 that are going to add together to give us negative 10? So if they're going to add together to give us negative 10, we know we're going to be working with some negatives. So those two are going to be negative 4 and negative 6. Those multiply to give us 24, add up to give us negative 10. Now, if you would please, your note packet to the section that's called 8.6, factoring when a is equal to 1. If you need to pause the video to make sure everyone's ready, then go ahead and do so. So to start, we're going to review how we multiplied. We spent one day working with algebra tiles, multiplying, and then we eventually worked toward, we don't need the tiles to keep track of things, we can actually, which in this case you can think of as FOIL because you have a binomial times a binomial. So we're going to review multiplication because multiplication and division are inverse operations, and if you understand how the multiplication works, we should be able to go backwards to do the division. So we would start by distributing the first x. So x times that x would give us x squared. That's the f in FOIL. X times the 5 would then give us positive 5x. Now this x is done distributing. Now I need to distribute the 3. 3 times x would give us 3x, and then the 3 times the 5s would give us 15. If I add all the like terms together, the middle terms of 5x and 3x, my final answer I would write is x squared plus 8x plus 15. You can see that from the diagram down here. X plus 5, x plus 3. There's the 5x's, there's the 3x's, making the 8x's in total. That we call multiplication. Our goal now is going to be to eventually work backward. I want to pick some things out though. So check this. Why is this a 15? The reason that is a 15 is because that came from 3 times 5. Why is this a positive 8? Because that came from 3 plus 5. That's a lot like the little math puzzles that we solved in the beginning. That's going to help us in a minute to go backward. So let's see if that pattern continues with the next one. So we're going to do one more multiplication, even with a positive and a negative. So distribute the first x times x to give us x squared. It needs to distribute one more time, minus 5x. Now it's done distributing. Now the 1 needs to distribute. That's why this is called multiple distribution, in this case double distribution. 1 times x is positive 1x, or you can just write x. 1 times negative 5 would give us minus 5. If I combine my like terms, I get x squared minus 4x minus 5. That's the answer when I multiply. Let's see if that pattern from before continued. Why is this a minus 5? The reason that that's a minus 5 is because it is a 1 times a negative 5. Why is this a minus 4? Because it is 1 plus a negative 5. That pattern continued. That's what's going to allow me to figure out what numbers these are when I work backward. So let's try a version like that. Let's say I have x squared plus 5x plus 6. If we were to be working with the algebra tiles, this is what we'd be asking. We'd be asking, how do I rearrange these items so that I would make a rectangle? So let's try it algebraically, and then we can check with the tiles. X squared plus 5x plus 6. We saw that the numbers I need when I'm trying to write this out in what we call factored form, these are the two numbers that made 6. So I need two numbers that are going to multiply to give me 6. So what are those? It could be 1 and 6, 2 and 3. But as we saw before when we were working it with the multiplication, it has to add up to be the middle term. So I need it to add up, so multiply to give me 6, and then it has to add up to give me 5. And that's what tells me the correct combination has to be a 2 and a 3. So I could write it out. It would have to be x squared plus 2x plus 3x plus 6, which then tells me it was x plus 2 and x plus 3. If you actually worked it the other way around, you would find when you multiplied, you would end up getting that. So from here to there is called multiplication. The other way around is our version of division. It's called factoring. You could always check by multiplying it back through. If you wanted to, you could use algebra tiles, or you could use a table. So I'm going to give you a chance to try just a kind of a simple one. So if you would, please pull out your whiteboard. See if you can work one backward like I just did. Can you factor x squared plus 7x plus 12? Can you find two numbers that are going to multiply to make 12 and add up to make 7? Let's pause the video now for maybe a minute. Unpause it once everyone's had a chance to try. Okay, welcome back. You should have found, so I need to multiply to make 12, add up to be 7. In your mind, what number multiply to be 12? Well, it has to be 1 and 12, 2 and 6, 3 and 4. Hey, we did one kind of like this in the beginning. I need them to add up to be 7. You'll notice I didn't write any negatives because I knew they needed to add up to be a positive 7. And they multiply to make a positive 12. The only way you can multiply to make a positive is either if they're both positive or both negative numbers, and they can't both be negative because they add up to be 7. The combination I need are the 3 and the 4. So it must be x plus 3, x plus 4. The order in which you write these does not matter. You could have written it as x plus 4 times x plus 3, and it would also be correct because multiplication is commutative. If you did the tiles, it looked like this: x plus 4, x plus 3. Those factors would give you the result of x squared plus 7x plus 12. So your answer is x plus 3 times a quantity x plus 4. Our goal is to write in what's called factored form. Factored form is when we write a quadratic as a product of two polynomials. We're going to be looking specifically at quadratics in this unit. So an example would be x plus 9 times x plus 2. Those are the factors. So we would say that this one is written in factored form. Standard form is when it's written all multiplied out. X squared plus 11x plus 18. These two are actually the exact same equation. One's written in factored form, one is written in standard form. We had that for lines, sort of. We had different ways to write equations for lines. We had y equals mx plus b, we called slope-intercept, and we also had point-slope form. There's also standard form, but that one's not very common. You'll note 9 plus 2 equals 11. That's why it's going to have to add up to be the middle term, and 9 times 2 is going to give us the 18. That's what tells us that this is factored correctly. When we're doing problems with factoring, the two steps are as follows. Step number 1 is going to be to do greatest common factor factoring first. That's why we reviewed it in a prior lesson. That's doing the distributive property backward. You need to divide out any common factors. That's kind of like simplifying the problem before you start. Step 2 then is once it's written out in standard form and all the common factors are divided out, you need to find two factors of c that add up to be b. You need to find two numbers that multiply to be c and add up to be b. Let's try it. So x squared plus 6x plus 5. I need to look, are there any common things I could divide out? Well, they don't have any number in common and they don't have any x's in common because this one has 2 x's, this one has 1 x, the last one has none. So there's nothing I can divide out. Step 1 is done. There will be times that I need to actually do something for step 1, and this is not one of them though. Now I need to find two numbers that multiply to be 5 and add up to be 6. What are the numbers that multiply to be 5? Well, there's only one pair I can think of. It's got to be 1 and 5, and that is what also adds up to be 6. So x plus 1 times x plus 5. And it's factored. You could check by multiplying it out, just writing it out, or you could use a table if you want to check. X plus 1, x plus 5, and then multiply it out. X times x is x squared. X times 1 is 1x. 5 times x is 5x. 5 times 1 is 5. And when you write it out and check, you get the following. So you know it's right. So step 2 done. Factored it. Try another one. Step 1, do greatest common factor factoring. This is an example where there is a step for step 1. You'll notice all of the numbers have a 2 in common, so I can divide a 2 out. If I divide a 2 out, what's left behind? Well, this first one only has an x squared. This 6 dividing a 2 out leaves me with a 3x. This was a minus 20, but I divided a 2 out. Now I have minus 10. So step 1 is done. I divided out any common factors. I can't divide out any x's because they don't all have an x. Now step 2 is to do the factoring we just learned about. I need two numbers that multiply to make negative 10 and add up to be 3. The 2 is just going to be out front when I check my answer. So I need to multiply to make a negative 10. If it multiplies to make a negative 10, I know that if it's negative, one of my factors has to be positive and one has to be negative. So if you think in your mind and write them out, you could have 1 and negative 10, or you could have negative 1 and 10. You could have 2 and negative 5, or you could have negative 2 and 5. But I need the combination that will also add up to be 3, and that combination is this one right here. So it must be the 2, and then the factors are x minus 2 times x plus 5. And then you would be done. You could check it by multiplying x minus 2 times x plus 5, and then we'll double all the items that we get at the end. X times x is x squared. X times minus 2 is minus 2x. 5 times x is 5x. 5 times negative 2 is negative 10. Squared plus 3x minus 10, which is exactly what I had in the middle, and I still had that 2 out front. So it gets me back to the original once I multiply everything out. So I did it right. So that's factored. It's in simplest form. One more that I'm going to give you a chance to try, and that'll be it. Step 1 is to divide out any items they have in common. And this one, it doesn't look like they might have something in common, but if there's a number out front, just like this one had a 2, it means you can divide it out. So this right here is actually a number. It's a number 1. It's actually a negative 1. So I need to divide a negative 1 out of everything because I want it to be in the form positive x squared plus bx plus c, where b and c could be negative numbers. But dividing a negative 1 out, what's it going to do to all of these items? It'll change their signs. This will be a positive x squared, now a minus 3x when you divide a positive 3 by a negative, and a minus 28. Now I need two numbers that multiply to make negative 28 add up to be negative 3. I'm not going to write out the combinations for the negative 28 one. I think you should start to be able to do it for yourself. But here's some context clues. You know it needs to multiply to be a negative. That means one of them has to be negative. And it also needs to add up to be a negative 3. That means the number needs to be negative so that when they add up, the result will be negative. So you think through your combinations. 1 and 28, that's not going to work. They're too far apart. 2 and 14, too far apart again. 4 and 7, though, are 3 apart. So that has to be the combination, and the negative needs to be with the 7 so that when they add up, they're going to add up to be a negative 3. Negative 7 plus 4 makes negative 3. Negative 7 times 4 makes negative 28. And it's factored. You could check by doing x minus 7, x plus 4. X times x is x squared. X times minus 7 is minus 7x. 4 times x is 4x. 4 times negative 7 is negative 28. Your result is x squared minus 3x minus 28, which is what the middle part was. There's still that negative 1 out front, which when you distribute it back through, it will leave you with the original result. So it checks out. Your chance to try. I'm going to ask you on the whiteboards to factor x squared plus 6x minus 16. Give you a chance to try one for yourself that has to deal with some positives and some negatives. So pause the video now for maybe a minute. Find the factors and then check your work using a table or multiplying it through by hand, however you'd like. So pause the video now, come back after a minute. Okay, this is what you should have found. You need two numbers that multiply to be negative 16 and add up to be positive 6. They multiply to be a negative, so one has to be positive and one has to be negative. They add up to be a positive 6, so the bigger factor has to be the positive one, and your numbers are going to be x plus 8 and x minus 2. And then you'd be done. You could always check it by multiplying it, distributing through. X times x gives you x squared. X times minus 2 is minus 2x. 8 times x is 8x. 8 times minus 2 is minus 16. You end up getting x squared plus 6x minus 16. So it checks out. You don't have to check with a table. You can just do multiple distribution. And that is it. That is what we would call factoring. There's one last critical thinking one that I'd want to show just because the book asks one like it. So let's say you have this one. It's x squared minus bx. So you know the middle term is negative. The last term is positive 12. Based on the following information, what are the possible values for that middle term? So we know the factors have to multiply to make a positive 12, add up to be a negative number. So if they multiply to be positive and add up to be negative, I know both factors need to be negative. So what are factors that will multiply to make a positive 12 that are both negative? Well, it could be negative 1 and negative 12. So it'd be minus 1x, minus 12x here. And that would then add up to be minus 13x's. So one possible value you could have is x squared minus 13x plus 12. So there's one possible situation. What's another one we could get? Well, we could have negative 2 and negative 6. In that case, that would add up to be negative 8x. You could have x squared minus 8x plus 12. There's one more combination that you might be able to find to be negative 3 and negative 4. Those will multiply to make a positive 12. What will they add up to be in the middle? They'll add up to be a minus 7. So those are your three possible equations. If you knew it multiplied to be a positive 12 and then added up to be a negative term in the middle. So there's one homework question, I believe, that asks about that. And even if it didn't, it's a good question anyway. So there you are. Thank you very much, and have a good day.